Welcome to the SPSS tutorial for paired sample t-test. This is Dr. Zapku, and in this tutorial we are going to learn how to conduct a paired sample t-test in SPSS. Let's begin by considering a research question for a paired sample t-test. The research question we will be exploring is there a significant change in students' math achievement scores following participation in a remedial math course? Accordingly, the null hypothesis in which we will be testing is there is no significant change in the students' math achievement scores following participation in a remedial math course. As we look at the research question and the null hypothesis, we note that the independent variable is the time between the pretest and posttest in which the students participate in a remedial math course. Our dependent variable then is the math achievement scores measured on 2 occasions. Thus, the paired sample t-test, sometimes referred to as the repeated measures t-test, is useful for analyzing the data collected to answer this research question, because the paired sample t-test is useful when you have only one group of people and you collect data from them on 2 different occasions or under 2 different conditions. In our example, we're looking at only one group of people on 2 different occasions, the pretest and then the posttest. However, you can also use a paired sample t-test when you measure the same person on his or her responses on 2 different questions. For example, I may ask about somebody's level of satisfaction in 2 different areas and want to compare them, or level of satisfaction with a relationship with a husband versus a relationship with a child and compare those 2. Now that you have a basic understanding of when a paired sample t-test is used, let's go back to our research question. Let's open SPSS and locate the data that we need to analyze to answer the question. To locate the data set on my computer, I'm going to open SPSS, then click File, Open, Data. This will open the Open Data box so that I can select the file with the data I wish to analyze. Here I select Dependent Test Tutorial, and I click Open. To progress in this tutorial, click the Open button. When the Open button is clicked, the selected data set will appear in the SPSS Data Editor window. We are now ready to conduct the paired sample t-test. Conduct the paired sample t-test. From the menu at the top of the screen, click Analyze, click Compare Means, and then click Paired Sample T-Test. To progress in this tutorial, go ahead and press Paired Sample T-Test. The Paired Sample T-Test box will appear. Click on one of the variables that you are interested in comparing for each of the subjects. Pretest is one of these variables. Click Pretest. Then click the arrow button to move the pretest variable into the variable 1 spot. Now that the pretest variable is in the variable 1 slot, click the second variable in which you're interested in comparing for each subject. In this case, we're going to compare the pretest with the posttest, so we click Posttest. And we click the arrow button. Click the arrow button to move the posttest variable into the variable 2 slot. To progress in this tutorial, go ahead and press the arrow button. Once you see that the posttest variable is in the variable 2 slot and the pretest variable is in the variable 1 slot, you're finished, so you can click OK. Go ahead and click OK to progress. SPSS will then begin to generate output for our paired sample t-test. Generated output. The first box that you'll notice is the paired sample statistics box. The information contained in this box is important to reporting your descriptive statistics for your results section. If you roll your mouse over the paired sample statistics box, you'll see how to report the descriptive statistics, or at least one way to report the descriptive statistics. When you're finished, click the pretest mean to progress in this tutorial. Next, we want to look at the paired samples test box. Here we will determine whether or not our t-test was significant and whether or not we can reject the null hypothesis. We begin by looking at the column labeled SIG two-tailed. This is our probability value. If our probability value is less than 0.05, because let's say that we set our alpha level at 0.05, we can conclude that there was a significant difference between our pretest and post-test. Since we look at this column and we see that it is 0.000, less than 0.05, we can conclude that there was a significant difference between our pretest and our post-test, and thus we can reject the null hypothesis. Also in this box, take note of the t-value and the degrees of freedom, the df. You will need these when you report your results section. I invite you to roll your mouse over the t-value, the degrees of freedom, remember df, and the significance level to view one way that you could report these statistics or these values in your results section. When you're finished, I encourage you to find the mean difference in the mean score. We're next going to talk about the mean difference because having established the significance results, our next step is to find out which set of scores is higher and lower and how much they differ. By looking in the paired sample test box, you can determine what the mean difference was between the mean scores in the pretest and the post-test. In this example, you'll note that the mean increase was 2.67. Note I said 2.67 and not 2.667 because when we're talking about this value in terms of APA style, we only use 2 decimal points. So, by looking at this paired samples test box, we can note that the mean increase was 2.67 with a 95% confidence interval stretching from a lower bound of 1.66 to the upper bound of 3.68. Again, you can roll your mouse over the mean column as well as the confidence interval column to view one way that you can report these values in your APA results section. When you're finished, click the mean column again to progress in this tutorial. Having examined the paired sample test box, we've established that there is a significant difference and that the difference between the mean scores is 2.67. I know I've been talking in terms of there's been an increase in scores, but really we can't determine this until we examine the paired sample statistics box. This will show us which score is higher and which score is lower. This box gives us the mean scores for each of the 2 sets of scores. In our case, the mean score for the pre-test we can see in this box is 37.5. For the post-test, it is 40.17. Therefore, we can conclude that there's a significant increase, not just a significant difference, but a significant increase from the pre-test to the post-test. As we're talking about this, something I really want to caution you is that even though we've obtained a significant difference between the scores after the intervention, we cannot say necessarily that the intervention caused the increase in scores. Research, unfortunately, is never ever that simple and that straightforward. There are many other factors called confounding influences or confounding variables that could have caused our math scores to increase. For example, simply maturation or growth or maturity could have caused those scores to increase. Perhaps students were exposed to another type of treatment or math instruction that could have caused our significant increase also. So for the most part, it's always a good idea and it's a better research design to have a control group that you're actually comparing if you are actually considering a question like the one that we're considering here. Before we can write a result section, we need to determine the effect size. Unfortunately, like the independent t-test, the paired sample t-test SPS output does not automatically calculate the effect size for us, so we need to calculate it. The formula for eta squared is t squared divided by t squared plus n minus 1. To enter the numbers from this SPS output into the actual formula, roll your mouse over n and determine the effect size. I challenge you, considering the guidelines presented by Cohen, remember 0.01 is small, 0.06 is moderate, and 0.14 is large, what's our actual effect size? Is it small, moderate, or large? When you're finished, click the T column to progress in this tutorial. Based on the SPSS output that we just reviewed, you could write the following APA results section. Take some time to read through this results section, then click anywhere on the slide to progress to our final slide. For completing this SPSS tutorial for paired sample t-test, you should now be ready to analyze your own data by conducting a paired sample t-test using SPSS.